All right, welcome to this explainer. Today, we are going to peel back the layers on something truly wild. Elon Musk's absolute, undeniable obsession with Mars. We're going to uncover the whole shebang, from the incredibly daunting orbital mechanics that make this trip nearly impossible, to a brilliant hidden Wall Street strategy that explains some of his most recent confusing moves. Look, if you've ever wondered what's actually driving this massive push to make humanity multi-planetary, you are exactly in the right place. So let's just dive right into it. To really wrap our heads around the scale of this mission, you have to hear this bizarre but honestly super telling anecdote from Tallulah Riley, Elon's ex-wife. She was recalling a time when he invited her back to his hotel room for the evening. Now, instead of a typical romantic date, you know what they did? They literally just sat there watching rocket videos. It's funny, but it perfectly establishes his unyielding obsession with space. This isn't just a fun side project for him. It's the core driver of his entire life. He's even explicitly stated that his main reason for accumulating wealth is just to fund this exact obsession. And you can see this in his businesses. When you look at Musk's portfolio, it kind of seems like a random collection of trendy tech companies, right? But map them out, and it's like a giant puzzle. They actually form a carefully constructed earthly ecosystem built specifically for Mars. Think about it. Tesla isn't just a car company. It's developing self-driving tech and those Optimus robots, which is exactly the autonomous workforce you'd need to build on a dead planet. Starlink, that's the exact satellite communication grid a Martian colony would require. The Boring Company is literally perfect for digging underground habitats to shield people from space radiation. Even X.AI and Neuralink fit right in for advanced problem-solving and human-computer interfacing. Every single move is totally calculated. So that brings up a pretty massive question. Why? Why is every single business he builds secretly pointing toward Mars? Why this relentless, almost crazy drive to leave Earth? Well, before we can even talk about surviving on the red planet, we really need to talk about the sheer physical nightmare of just getting there. The level of mathematical precision required is, well, it's almost hard to comprehend. To answer that, we've got to look at the sheer physics of our solar system. Earth and Mars orbit the sun at totally different speeds. At their furthest point, they are a staggering 400 million kilometers apart. You can't just fuel up a rocket and launch whenever you feel like it. You have to wait for this very specific launch window, when the planets align and that distance shrinks down to about 55 million kilometers. Here's the kicker, though. That window only opens once every 26 months. If you miss it, or if you have a single launch failure on the pad, you are literally twiddling your thumbs waiting over 2 years for the next attempt. There is absolutely zero room for error. And to make it even tougher, you aren't just flying in a straight line. Rockets use something called a Hohmann transfer orbit. Think of it like a quarterback throwing a football to a receiver sprinting down the field. If you throw the ball to where your friend is right now, by the time the ball gets there, they're long gone. You have to aim for where they will be in the future. That's exactly what a rocket has to do. It aims for the patch of empty space where Mars will be 7 to 9 months in the future. The calculations have to be flawlessly perfect. Okay, so let's assume the math is absolutely perfect and we manage to land. Boom! Welcome to Mars. The very first thing to greet you, a bitter, freezing average temperature of negative 60 degrees Celsius. And at night, it plummets below negative 100 degrees. To put that into perspective, Antarctica, literally the coldest place on our entire planet, has an average temperature of negative 49 degrees. Mars is significantly colder and vastly more dangerous. Step outside unprotected and you're an instant ice cube. But honestly, the freezing cold isn't even what's going to kill you first. Mars has an incredibly thin atmosphere with practically zero breathable oxygen. If you were to somehow stand on the surface without a specialized spacesuit, you wouldn't just be able to hold your breath for a bit, you would instantly suffocate, facing completely fatal consequences in under 90 seconds. Then there's the gravity situation. Mars has only 38% of Earth's gravity. Now I know, that sounds incredibly fun at first. Actually, if you weigh 70 kilograms on Earth, you'd only feel like you weigh about 25 to 27 kilos on Mars. You could jump way higher, carry super heavy things around like it's nothing. But, and this is a massive but, that deceptively fun statistic leads directly to what scientists call the silent killers. Our bodies evolved for Earth's gravity, right? So low gravity rapidly degrades the human body. We're talking severe bone density loss and massive muscle shrinkage. Add to that the fact that Mars lacks a magnetic shield, meaning you're constantly bombarded by cancer-causing, DNA-destroying space radiation. Oh, and if that wasn't enough, massive, totally unpredictable dust storms can sweep across the entire planet, blocking out the sun for months at a time. It is a wildly hostile, dead world. So, Knowing all of these terrifying physical threats, you have to ask, why on earth would anyone want to go? Well, this brings us to the deep existential philosophy driving the entire mission, and it's summed up in one haunting question. Where is everybody? This is the core of the famous Fermi paradox. Imagine a massive school with 10,000 classrooms. Logically, there should be students inside them, right? But when you walk the halls, every single classroom is completely empty. That's exactly how scientists view our universe. With billions of galaxies and habitable planets, mathematical logic says there must be other intelligent life out there. And yet, we haven't found a single trace. The really terrifying solution to that paradox is something called the Great Filter. It's this theory that suggests there is a catastrophic barrier out there. Maybe it's nuclear war, climate collapse, or a giant asteroid that just wipes out advanced civilizations before they ever get the chance to expand. Musk views this Great Filter as a ticking clock. If humanity stays entirely on Earth, all of our eggs are in one very fragile basket. His core argument is that we absolutely must become a multi-planetary species right now, essentially building a backup drive for humanity before an inevitable extinction-level event hits our only home. So how do you actually execute an insurance policy for the entire human race? Simple. You build the biggest rocket in human history. SpaceX's Starship is a staggering 123 meters tall. For some context, it absolutely dwarfs the famous 72-meter Qutb Minar. It's massive, but the size isn't even the coolest part. It can carry 100 to 150 metric tons of cargo in a single trip. And unlike the rockets of the past that were basically multi-million-dollar fireworks you use once, Starship is designed to be fully reusable.
Okay, let's break down the actual step-by-step master plan for terraforming and colonizing Mars. Step 1, send starships loaded with those Tesla Optimus robots we talked about. They'll use local resources to build automated, self-growing habitats before humans even set foot on the dust. Step 2, send a small crew of scientists and engineers to supervise and expand the base, actually living out of the starships at first. And finally, Step 3, mass scale. We're talking launching fleets of hundreds then thousands of ships, with ticket prices hopefully dropping to roughly $500,000 per person. The ultimate, awe-inspiring goal here? 1 million people permanently settled on Mars by the year 2050.
But listen, there is a massive elephant in the room here, and that is the cost. The upper-end estimates to fully achieve this Mars master plan, they hit a staggering $1,000 trillion. Just to put that totally mind-bending number into perspective for a second, the entire global economy right now is only around $110 trillion. That's almost 10 times the amount of money that exists on our entire planet. To pull this off, they desperately need revolutionary ways to cut costs. Which actually brings us to a highly theoretical but absolutely fascinating scientific concept: gravitons. These are hypothetical subatomic particles that physicists believe carry the force of gravity, kind of like how photons carry light. Now, scientists could discover and somehow manipulate gravitons, it would completely change the game. By controlling gravity, we could drastically cut the immense fuel costs needed for heavy rocket thrust. On top of that, we could generate artificial gravity inside the spacecraft, which would entirely solve those terrifying bone and muscle degradation threats to astronaut health. I know, it sounds straight out of science fiction, but it's exactly the kind of massive technological leap required for a mission this huge. Okay, so the plan is set. The ultimate vision is Mars. But then, earlier this year, a massive plot twist happens. In February 2026, Musk suddenly comes out and announces that building a city on the moon, not Mars, is now the immediate priority for the next 10 years. Wait, what? Why on earth would you abandon this long-held Mars narrative to suddenly pivot to the moon? Let's look at the first layer of this decision: space logistics. Frankly, the moon is incredibly forgiving compared to Mars. Traveling there takes just 3 days, not 7 to 9 months. And remember that super stressful 26-month launch window for Mars? Well, the moon's launch window opens up roughly every 10 days. By partnering with NASA's Artemis program, the moon offers this rapid, highly iterative testing ground. If a test fails, you don't wait 2 years, you literally try again next week. It's the perfect sandbox to safely figure out habitats and robotics before tackling the deadly Martian surface. But there's a deeper, second layer here. Let's talk about Wall Street for a second. SpaceX is gearing up for a highly anticipated IPO in June. Now, investors love a grand, world-changing vision, sure, but what they really demand are visible returns within a 5 to 10-year time frame. Mars is a 20 to 30-year dream that is incredibly high risk. The moon, however, that is achievable right now. By pivoting to the moon, Musk provides immediate proof of capability. Honestly, it's a brilliant psychological move to calm cautious investors and drive up that IPO valuation by showing them quick, tangible wins. And there might even be a third, hidden layer here, a classic Elon Musk psychological trick. Let me tell you a story. Back in 2021, the Raptor engine they were building was way too complex and costing an unsustainable $16 million to make. Musk demanded the team cut the cost down to just $1.6 million. When the team said it was impossible, he fired the head of the project and suddenly ordered everyone to completely abandon the Raptor to build a brand new, hypothetical 1377 engine. Just weeks later, he pivoted them right back to the Raptor. Why? He was forcing them to shatter their mental barriers and think creatively. And the crazy thing is, it worked. They rapidly innovated and slashed costs. It's entirely possible this sudden moon pivot is just another deliberate shock to the system, designed to force his engineers to think completely out of the box. Now, a lot of scientists and critics look at all of this, the insane costs, the brutal logistics, the terraforming, and they just call it pure madness. But let's take a quick look at history. In the 15th century, Columbus sailed west when so many thought the Earth was flat. In the 17th century, Shivaji Maharaj seemingly did the impossible by rising up and successfully challenging the massive Mughal Empire. In the 20th century, the Wright brothers were literally called crazy for trying to defy nature and fly. History constantly proves that world-changing figures are always deemed insane by their contemporaries, right up until the very moment they succeed. Which really leaves us with this final, profound question. Do we just stay here on Earth, waiting for a natural disaster, a great filter, or some catastrophic event to eventually wipe out our only home? Or do we push the absolute boundaries of science and economics to build a backup planet for humanity? Whether Elon's grand insurance policy ultimately succeeds or fails, it is unarguably one of the most fascinating endeavors in human history. Thank you so much for joining me for this explainer. Keep looking up and stay curious.